Hi, my name is Daniel Callander, and today we'll be talking about the transition and translation methods between IPv4 and IPv6. This is what my project is based on and will be showcased in this video. The main two that I will be discussing is tunneling and dual stack. I started off using tunneling for my project, however due to time constraints I needed a physical working network, and dual stack was a working alternative that I could get working. As you can see in front of you, this is the network diagram. It is a very simple network. Two routers run down to switches with 4 end devices on each side, 2 servers and 3 client PCs. Each of the servers are running DNS and DHCP to create a domain for the users, and the DHCP to give out the addresses. The routers will be running OSPF to connect the two networks together, and of course the dual stack in the middle for the IPv4 and IPv6. Moving on to the server for the network, as you can see, all the OSs are virtualized, as this is a lot easier to use than actually physical hardware, as I can take this anywhere and use it anywhere with the software. So first I'd like to talk about the domain for the network. The IPv4 domain is shown here. This is the Windows User 2018, and on the Windows server we have the project IPv6 domain. The very different names. Unfortunately my naming scheme was not the best at the time, but this is the way it was used. The domain is used for giving out files to users, giving out the actual usernames you set up through the domain. So you need to join the main to log into your account, so all the user PCs are set up on that domain. The actual lookup zone is called project.uclan.ac.uk. That'll be shown on the network card interface on the actual PC. As shown, we move to the IPv6 network. We have the project IPv6uclan.ac.uk domain instead of a internet connected there. Next we move on to DHCP. So DHCP hands out addresses to the network and all of the users and client devices. The server has a set IP address. Obviously we don't want that being given out, given an address, as they all need to connect to that. So showing here, we go into the DHCP manager on the server, and we go through, and for dual stack obviously you have to set up both IPv4 and IPv6, so each scope is set up differently. Here is the IPv4 domain, DHCP sorry, and the IPv6 DHCP. This was going through a simple wizard process of right-clicking the IPv6, clicking new scope, and going through the wizard process as seen here, giving it a name, so on and so forth, and coming out with the right IP address. And this is the network IPv6 on the IPv6 side and the IPv4 on the IPv6 side. Going back to the DNS was also set up through a very similar wizard process. So now we have a very simple network set up, but they can't talk to each other. This is where the routing and the dual stack come in. So for my routers, I'm using a BIOS interface. As you can see, there's 2 interfaces coming. One connects obviously to the other router and to the network. We are looking currently at the IPv4 router. The ETH0 is going to the other router, and the ETH1 is going to the PC. As you can see, they have both IPv4 and IPv6 addresses. This is to make the dual stack work, as you need both to connect to each other. Going on the show config, we can see that I am running OSPF. This is a very efficient protocol. It helps with obviously routing traffic, and as you can see, the two networks are right there. I can't show you a mouse, never mind. With the 198.0.0 and the 10.0.1.0. And then that is for the OSPF for the IPv4. Then OSPF version 3 is for IPv version 6. This again, this is set up a bit differently. You have to actually run the command to set a range for the network. That, as you can see, the three networks there, and then also assign that range to the interface. That's why it's displaying ETH1 and ETH0. And just for consistency's sake, I'll show the same. As you can see, the interface is there, one connected to the other router and one connected to the other network. The same thing here. Going down, we have obviously the IPv4 OSPF and the IPv6 OSPF. This is then working at the same time to give out. You make sure the network can connect and talk to each other. So if we move to the this is the IPv4 user PC, using the diagram as reference. This is user 2, just because it's the one I had loaded up. So this is the network address for the IPv4 IPv6 side, the network with the IPv4 address. As you can see, they're connected, and connectivity is being shown on the IPv4 side and also on the IPv6 side. Going back, these addresses were obviously given out by the DHCP. If we go back and look at the DHCP, we can go into the manager and see that leases are being given out. If we go into scope, and oh no, that's the address. There we go, address leases. 2 address leases for 2 different users I've had loaded up. If we go on to the IPv6 server and go into the DHCP, again into the DHCP manager, and we can see that they are being given out IPv4 and IPv6 addresses. Tunneling will work differently. This will create a tunnel across 2 wires in between the network. This is the difference between dual stack and tunneling. Tunneling's a lot easier because it doesn't require you to send out both IPv4 and IPv6 addresses, as you can see from the notes I've made on the diagram. Tunneling would only require you to send out one for the correct one you would like on that side of the network. So therefore, I believe it would be more applicable to have tunneling in a large organisation. Dual stack would take a lot longer to set up and with a lot more manpower needed. This has been my project. I hope it's been informative. Thank you very much.